Are two integers equal in some base? Disclaimer, this problem is purely for fun. There may already be a solution. I've searched, no luck. I have several questions below. I'd appreciate an answer to any of them. Ryle. I was inspired by a Three Stooges video I saw earlier, where it's shown that 13 by 7 equals 28. You may have seen it. But I started wondering, is there some base in which this equation is true? I put base in quotations because I'm using the term in the wrong sense. See the final paragraph for what I mean? The answer is clearly no, if we define multiplication the same as for integers. If you break up 13 into base I, say 13 equals 1i plus 3, and 28 equals 2i plus 8, the multiplication factor of 7 ensures equality won't happen. Okay, but now suppose you want to ask the question, is there some base where two numbers are equal, say 8 equals 10? I'm probably using the term base wrong, sorry for that. What I mean is, if we write 8 equals 00, 8 equals 0 times 8 squared plus 0 times 8 plus 8, 10 equals 010 equals 0 times 8 squared plus 1 times 8 to the power of 1 plus 0, then according to my, clearly wrong, usage of base, we have equality. I wrote some simple code, up to 3-digit numbers, to verify this. But my code sucks. Sorry if your eyes hurt from that hideous code. I didn't even use NumPy arrays. What I'm wondering is, has this problem been solved before, for arbitrary digits? If not, I wanted to be flexible about the number of digits entered in N1 and N2. Is there a more clever way to define the functions t1 and t2 so that they adaptively expand in base I, depending on the number of digits entered? Performance-wise, I'm sure there's a better way to do my main iteration. This is the fun part for me, combined with the answer to part 2. Any suggestions? If it happens that t1 and t2 forever remain ordered the same, as in the example from the code, the iteration will play out 2 6 times. The iteration number was chosen arbitrarily, but one could imagine if we extend it to many digits, one might need even more iterations. Surely there's a more clever way to stop the iteration. Is my stopping condition just wrong? Thanks so much for reading. This is not a homework assignment and the answers are probably completely useless. I'm just interested in seeing a real coder's take on it. It would be neat if this wasn't an already solved problem. Much love.
You can make the problem simpler by applying a little bit of number of theory. Taking your first example 13 by 7 equals 28, we can expand this out into an explicit polynomial over the base, 1n plus 3, 7 equals 2n plus 8. If this solution has real roots, then the roots are values of n, bases, for which the equation is true. If you like this sort of problem, then you should read Computational Number Theory by Shoup. It's a fun book.